Hello, Math 30s. We're going to do the lesson on solving rational equations. Your notes look a little bit different than this, I see now. The title's the same. I just updated something and haven't updated this smart file, but I'll kind of read from the file that you guys have. So it says, today we work with equations. So up to this point, we've been working with what we call expressions, in that they were not equal to anything. So we were just simplifying it, right? We were multiplying, we were dividing, and we would end up still typically with a rational expression. So not equal to anything. So now we're talking about rational equations. So the difference between an equation and an expression is simply the presence of an equal sign. And so this typically, this first unit I always say is kind of one of the tougher ones in Math 30 for some people. Some people it's actually really easy for, but I usually find this is the point where the wheels really fall off, because you need to keep your rules for expressions versus equations separate, because you're going to see something that's similar, but it's different, and I find that people start flopping the rules all over the place and it doesn't go so well. So your notes say one method to solve a rational equation is to, so your first step is factor completely if possible. We saw this with rational expressions as well. I always said factor it out first because it might make something easier. So if you have multiple binomials or trinomials or anything like that, make sure you factor out any common factors, because that can make things easier. Determine the common denominator. Best case scenario is the lowest common denominator. If you end up with any common denominator, it's still going to work. It just might make more work for you. So you want to try to go to find your common denominator. And so your last little bullet point there says multiply all terms in the equation by the common denominator. Sorry, but next to that next bullet, you might want to write not your lowest common denominator divided by your lowest common denominator like what you had before, but just multiplying it by the lowest common denominator. And that doesn't really make sense until I show you an example of what I mean by that. So kind of some baby steps that just lead into this. So just skills that we should have in order to do this part is just thinking about things that we know. So this right now, this first one is an expression. It doesn't have an equal sign. We're not solving for x. We're just going to use our distributive property to multiply that 12 by each term in the brackets. So 12 times 3x is 36x, and 12 times 5 is 60. Okay, so that's a baby step that will be important at some point. This next one is kind of our rules for multiplying fractions, which we looked at previously. Again, we're still dealing with an expression here. So if not having a fraction stresses you out, you can write it as 12 over 1. Because we know when we multiply fractions, we multiply numerator by numerator and denominator by denominator. And we need to do that 2 times because, again, you have your distributive property. So I have my numerator of 12 times 3x is 36x, and a denominator of 1 times 4, which is 4. And in the other one, I have numerator of 12 times 5, which is 60, and 1 times 3, which is 3. From here, hopefully you can kind of see like 36x over 4 and 60 over 3. That can be simplified further. Having 36 over 4, those both have a common factor of 4, or 36 divided by 4 is equal to 9. So 36x divided by 4 is actually equal to 9x, and 60 divided by 3 is actually equal to 20. Sorry, I kind of ran out of room there. Sorry. Got a tickle again. And so I'm not sure where I wanted to go with this one. Let's just hop along to question 1 here. You can do that one again. In the end, you'd want to be solving for x in that case because we have an equals sign there. So, Oh, this is straight up different than yours. Let's not go on to that. Let's go on. Oh, this smart file is annoying. But this is the question. Okay, so this is the question that you have as question 1. I do too. I changed the file and then I forgot to change stuff. So question 1 is 3x over 4 minus 5 over 3 equals 7 over 2. So before we had stuff like this, so we had something like that, and we knew we would try to get it over a common denominator, and then we could combine it. But we've added in that part that now it's equal to something. So what we're actually looking for in these is values, it can be more than one, a value or multiple values that can make that equation true. And so if you're stuck, I guess you could sit there and be like, what if I put in x equals 1? And you could put in 3 times 1 divided by 4, subtract 5 over 3, and get some gobbledygook out of your calculator, and then put 7 over 2 in your calculator and see if it's equal to the same thing. Hint, it's not. So you could do the old plug and chug where you try values for x and you hope for the best. I'll tell you now, this first one, it would take you a real heckin' long time to be able to guess the value for x that actually makes this true, because it's not a whole number. It's a decimal. It's yucky. Quite often they are whole numbers, but trying to go through every whole number or every integer and try to figure it out is not going to be so much fun. So let's talk about the right procedure. So those bullet points above, again, is factor completely if possible. Nothing I can factor in that one. Determine the common denominator. Again, best case scenario is the lowest common denominator. And multiply all terms in the equation by this common denominator. So I see I have denominators of 4, 3, and 2. So if I got desperate, I could do 4 times 3 times 2 is going to be a common denominator. But I recognize that in terms of multiples of 4 and 3 and 2, 12 is actually my lowest common denominator. Again, you could do 24, which is, so a common denominator could be 4 times 3 times 2, which is 24. That would still work out. Don't panic if you were like, oh, I didn't recognize 12, that's no good. 24 is going to work out. Just when we get into binomials and stuff, it just makes quite a bit more work for you. So hang on a second. Here we go. That's better. So what it said in the next part, it said multiply all terms in the equation by the common denominator. So we're not doing the common denominator divided by itself. What I'm doing is I'm going to multiply each term by the common denominator. So that common denominator of 12 multiplied by each term. So now this is applying in what I do to one side of the equation. So I've done it here and here. I have to do to the other side of the equation to not be changing the value of the equation overall. So I'm multiplying it in each spot by that common denominator, hopefully our lowest common denominator. And so now this kind of looks like a question that we had up above, I guess not entirely, but what we're going to do is follow those. Sorry, I have like something I need to cough and it's not coming out. So I need to multiply that through now. So we're going to multiply it in, multiply it in, multiply it in. So what this step of multiplying by the common denominator does is it's going to get rid of all of these fractions. And then stuff's going to start to look a lot nicer. So 12 times 3x is 36x. Again, this is 12 over 1 if you need that in your brain. So now we have 36x over 4. 12 times 5 is 60. 12 times 7 is 84. So at this point, you might be like, you said we were getting rid of the fractions. Well, it doesn't look like we've gotten rid of the fractions yet, but we can simplify from here. All of these fractions can be simplified. So 36 divided by 4 is 9x. 60 divided by 3 is 20. And 84 divided by 2 is 42. So now that's looking a whole heck of a lot nicer when we're trying to solve for x. That's what we're doing in the end, is we're trying to isolate x, get it by itself. So I'm trying to solve for x. So now we want to get x by itself. So how do I get x by itself? Well, we've got to move everything. So thinking about opposite operations. So right now I have 9x plus 20. So I'm going to subtract 20. What I do to one side of the equation, I need to do to the other side of the equation. Sorry, I was like, something seems wrong here. That's because, hopefully you're yelling at me, this is a minus, not a plus. Boop, boop, boop. So this would be plus 20, plus 20. So I'm going to add 20 to both sides. Sorry, if you missed what happened, I just did a terrible transcription error that I wrote 9x plus 20, but it's 9x subtract 20. So I need to add 20 to both sides of the equation. So now I have 9x equals 62. And so now in order to solve for x is I need to divide both sides by 9. What I do to one side of the equation, I must do to the other. So now I have x equals 62 over 9. And so what that is the answer for x that makes this equation true. So the nice thing is with this part, it's easy to check your answer. So we can verify this by substitution. Meaning in the original equation, the one that was typed on the page, we need to substitute in x equals 62 over 9. So if I keep extending this page, so x equals 62 over 9. So 3 times 62 over 9 over 4 minus 5 over 3 equals 7 over 2. So this whole thing, you're probably going to want to smush into your calculator because I don't know the value of 62 over 9 to any number of decimal places, but I can punch that in. So 3 multiplied by 62 divided by 9 gets me 20.6, blah, 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 blah. And then if I divide that by 4, I get 5.16, blah, blah, blah. And then if I subtract, and I'm going to put brackets around it, 5 divided by 3. And then I close the bracket and press enter. I get an answer of 3.5 here. And then if I put 7 divided by 2 in my calculator, I get an answer of 3.5 here. So my left side of the equation equals the right-hand side of the equation. So my answer of x equals 62 divided by 9 is correct. So the nice thing is you can verify these because, again, we're looking for the solutions for x that make the left-hand side equal to the right-hand side. Okay, so now, yes, this is the number 2 question. I don't know what this is. Is that on the next page? No, that's garbage. Get it out of here. So this is the number 2 question that you have on page 23 there. So 5x minus 4 over 3x minus 1 equals 3 over 2. So we're looking for the value for x that would make that true. So we have 2 denominators. We have a denominator of 3x minus 1, and we have a denominator of 2. So our lowest common denominator is going to be equal to 3x minus 1 multiplied by 2. And I'm going to leave it factored out like that because it makes things nice and easy to cancel and to kind of see as we cancel. So again, we call it the plug and chug, where you plug something in and you just work through it and hope that it's the right answer. And if it's not, maybe you go into the next whole number. You might get there, but you also might not. So the real way to do it is by using this lowest common denominator. And remember what we said is we're going to multiply all terms in the equation, both on the left-hand side and the right-hand side, by that lowest common denominator. Whoa, come back. So again, I'm multiplying each term, both on the left-hand side and the right-hand side, by that lowest common denominator. So what I'm going to do now is go to my colored pens, because you guys know I like making things fancy. So what I can see is now I am multiplying by something that I have in the denominator in both cases here. So I have a 3x minus 1 as a numerator and a denominator. I have a 2 as a numerator and a denominator. So once I cancel some things out, you see now I no longer have the fractions, just like we did in that last question. So now it's going to get a lot easier to solve for x. So what we'll be left with there is, I'll kind of write all the steps out, 2 times 5x minus 4 equals 3x minus 1 times 3. And so now distributive property with both. So multiplying the monomial through the binomial. So what I will have is 10x minus 8 equals 9x minus 3. And so now what we want to do is pull all our x's on one side of the equation and all our constants onto the other side of the equation. So I'm going to subtract 9x from this side because 9x minus 9x is what we'll want to do. What I do to one side of the equation, I need to do to the other. And I'm going to add 8 to both sides to move that constant over as well. So 10x subtract 9x is going to be x, and then negative 3 plus 8 is going to be equal to 5. So the value that should make this true is a value of x equals 5. So again, these questions, you can verify your answers real easy. So you can know for sure if you are right. The only thing you won't know is if you're wrong, what you did wrong. So substituting in a value of x equals 5. So we had 5x minus 4. So anywhere there's an x, I'm going to put a 5. Oh, I'm going to run out of room, aren't I? Oh no, what have I done? Okay, so we're verifying. So 5 times, so we said x is equal to 5. 3, again, we said x is equal to 5, so I'm going to substitute that in. So now just kind of doing the arithmetic out. I can't get it out, whatever this cough is that's come from nowhere, and I can't go reach my water, it's too far away. So 5 times 5 is 25, 25 subtract 4 is 21. 3 times 5 is 15, 15 subtract 1 is 14. So what we have is 21 divided by 14 is equal to 3 over 2. If you don't recognize it right away, you could do 21 divided by 14 in your calculator, and you'll get 1.5. And you could do 3 divided by 2 in your calculator, and you get 1.5. And since your left-hand side of your equation equals your right-hand side of the equation, you know that you've got to the right answer. The only other thing, so with that last question, so our question 1, at no point did I have x in my denominator. So we didn't have any restrictions on the variable in that one. In this question 2, we actually do have restrictions on the variable. So we need to look back kind of at our original equation in order to figure out the restrictions on the variable. So we know, based on this portion that I kind of crossed out, we have a restriction on x. And so you could figure that out by going, we know that we can't have a denominator equal to 0 because you can't divide by 0. So we want to figure out what makes that equal to 0. So we have a restriction of x cannot be equal to 1/3 because that would make our denominator equal to 0, and you cannot divide by 0. All right, I think what I'm going to do is I'm going to split this into 2 lessons because I actually need to leave right now. So I'm going to record another one either tonight or tomorrow morning, and it'll have questions 3 and 4 on it. And then I might also actually do one of the homework questions because there's one kind of thing missing that's important. So expect another video.